All of you keep reading. Next one, electronic configuration. So this is already we studied in Bohr's atomic model. The same thing again we are going to study, and this is the most important one compared to all the things. Unless you know this, you cannot find the valency. So once if you understand this only, we can go with the next one called as valency. So right, electronic configuration. Okay. So now, right, electronic configuration means you can write shortcut. Electronic configuration means the complete the complete profile of an element. The distribution of electrons in different cells are energy levels in order of increasing energy or the arrangement of electrons in different cells in an atom is called electron arrangement, or we can say electronic arrangement or electronic configuration. Your choice. Electronic arrangement or electronic configuration. That is you have to remember. Now, all of you remember, I already taught you in the energy order of different cells. So how it will be? Which cell will be having more energy? The cell which is closer to the nucleus or the cell which is far away from the anyone?
Far away.
Far away from the nucleus. So when we are moving away from the nucleus, as we know, Mr. Bohr's represented with the names. Can you tell me the names of that? K, L, M, like that it will go. So now, please learn that the energy order. What is the energy order? Anybody can tell me? Energy order in the cells. How it will be goes? Different cells. Energy order of cells. Yes, please. How it will be? K is less than, L is less than, M is less than N. So who is the highest energy level? Highest energy
N, sir.
N cell. That is not you have to remember. Okay, everybody? Clear? Yes? So that is what you have to remember. Clear, everybody? So that is what you have to remember and you have to write it. So this is the energy level order. K, L, M and N. So who is the highest energy level? N, and lowest energy level is K. So now the cell which is near to the nucleus always low energy. Who is near to the nucleus? All of you? Who is near?
K.
That is what you have to remember. The cell which is near to the nucleus has low energy. Okay. So, and this kind of energy arrangement is given by two scientists. I told you. Of course, it is, we'll say Bohr's atomic model, but it's not two scientists. What is that? One is
Boron.
another one is what? Bury. Okay, Bohr-Bury scheme gives the maximum number, gives the maximum number of electrons accommodated, can be accommodated can be accommodated in a shell of an atom. So, what is that formula? Anybody? They have been arranged different things. What is the first one? The maximum number of electrons we can arrange. The formula what?
2n square, sir.
2n square. The maximum number, please write. The maximum number of electrons in different cell shell can be calculated by the formula. So what is the formula, everybody? Which is equals to what? 2n square. Now n is equals to what, guys? N is equals to what? Number of cells. Okay, that is what you have to remember. So if you have taken K, for example, K, what is the cell number? Shell number, name of the cell. Yeah, name of cell and number. Number of cell what? 1. So maximum number of electrons which we can accommodate 2 into 1 square, which is equals to 2. Same way, name of the cell L, name of the cell N, and name of the cell M and N. So number of cell, what is the number of cell? 2, 3 and 4. So 2 into 2 square, which is equals how much, guys? 8. Next, 2 into 3 square, which is equals to how much? 18. 2 into 4 square, which is equals to 32. So like this, the maximum number of electrons we can find, which we can accommodate in a given cell. So please, all of you remember, for calculating number of electrons in a given cell, we can use a formula 2n square. That is what you have to write it. Please make it. Okay, next. And one more thing. If it is the valence cell, all of you should remember. What do you mean by valence cell? All of you. Suppose if I have taken outermost cell or valence cell, all of you keep on remembering. If it is the outermost cell, whatever the cell it may be a K cell or L cell or M cell or N cell. If it is the outermost cell, understanding? Now, if I have taken this is, for example, what is the outermost cell? Can you tell me? What is the outermost cell now? In this case, K, L, M. M is the outermost cell. If I take one more atom, now in this case, what is the outermost cell? Everybody, now K and L. So here the outermost shell is L. And here, what is the outermost shell? M. So like this, whatever the shell it is, we cannot keep the electrons more than 8. That is what we can say valence cell or last cell. So if valence cell having only one, that is K shell, maximum how many electrons we can accommodate? Only one K shell. Maximum only we can accommodate 2. So other than K, okay, whatever it is, L or M or N, or the valence cell, maximum how many electrons we can accommodate? Everybody. maximum 8 electrons only, okay, present or accommodate in valence cell. That is what you have to remember. Okay, everybody? Yes, please. That is the second point. Right. The last shell or valence cell, second point. The last shell only what we can call valence cell. Okay. Valence cell other than K. If only K is there, how many we can keep, guys? Maximum. Everybody. If only is there. If only one shell, only K is there, then only how many we can keep, Mr. Sanjay? Akhilan? Only we can keep 2 alone. Okay? That is what you have to remember. That is other than K, then only we can keep 8. The last shell or valence cell cannot have more than 8 electrons. 8 electrons, even if it has the capacity, okay, to accommodate more electrons. Okay, so what do you mean by that? See, for example, if I take M shell, what is the maximum capacity? Everybody, what is the maximum capacity? 18. But if M is the valence cell, maximum how many? What is the maximum? If M is the valence cell, maximum how many electrons? Only 8 electrons. Understanding? So their original capacity is different. But if it is a valence cell, only maximum how many electrons we can? All of you. Only we can. How many, Amma?
8.
We
8, sir.
can make only 8 electrons. That is you have to understand. Understand, Mr. Gokul, Kaushik? Okay. So irrespective of their capacity, if it is a valence cell, then maximum how many electrons we can? Only 8 electrons we can make it. That is you have to remember. Okay, guys? Yes, please. Next, last, third point. Third point is you can see randomly you cannot sit, like suppose movie theater. You can go wherever you want, you can sit, where middle row or last rows or balconies or whatever. Like that, electrons cannot. Electrons, they cannot fill randomly. Only they are accommodated in a given shell unless the next cell is filled. Means the inner cell is filled, only the electrons will come to the next cell. That is what you have to remember. They'll be filled based upon energy level. Okay. So right. Cells are filled stepwise as electrons are not accommodated in a given cell unless the inner shell are filled. Inner cells are filled. That is what you have to remember. Okay. So this is what is electronic configuration also. So you have to remember it. So till here, all of you should finish it. Then you can see, now I will show you this one in our book. You have to draw whenever you are free today. I don't know, but you must learn what this tabular column. I think 18 elements are there. This 18 elements, this 18 elements still are gone. These are all the things you have to draw, and as well as this tabular column also you should learn. So this is your responsibility. So here they have mentioned clearly atomic number, number of protons, number of neutrons, number of electrons, and how it is distributed, and what is this valency. So this valency, that is also I will say you. So this all the things, all of you, valency alone you leave it. Last column alone you can leave it. That valency will discuss in our next class. Other than this, you have to complete all the things. Means till the distribution. So this distribution also we will study. It's not an issue. But this up to here, number of electrons, this tabular column, atomic number of protons, number of neutrons, and number of electrons. This distribution and valency I will teach you. We'll discuss in the next class. But this all the 18 structures you have to draw, because exams surely they will ask you any two, whomever it is. Definitely they will ask you to draw any two in the exam. So that is why all of you must practice all these 18 structures in our classwork. Is it okay, guys? All of you? That is what you have
Yes.
to remember that. So by tomorrow, you must finish it. All these 18 structures plus this tabular column till number of electrons. So that is also 18 only. So till 18 elements, you have to learn order wise, and you have to learn their atomic numbers and number of protons, number of neutrons, and number of electrons. Later, that electron distribution of electrons, electronic configuration, and valency, I'll teach you in the next class so that you will understand. And types of valency also there. That is also I will teach you. So because here you will find somewhere 3,5 like this. That is what we will say variable valency. So that is also we'll discuss in our tomorrow's class. So with this I will stop. Hope you all understand, and we'll meet in the tomorrow's class. Thank you, everybody.
Thank